Hello, this is Bill and Purin, and today we're going to talk about Section 4, Symmetry.
A figure has symmetry if there is an isometry that maps a figure onto itself. So now let's take a look at the key concepts and types of symmetry. The first type of symmetry is line symmetry or reflectional symmetry. A figure has line symmetry or reflectional symmetry if there is a reflection for which the figure is its own image. So at the right, as you can see, the lines are lines of symmetry, which are lines that divide the figure into congruent halves. So a figure can have many lines of symmetry. These lines can be vertical, horizontal, or even diagonal. The second type of symmetry is rotational symmetry. A figure has rotational symmetry if there is a rotation of 180 degrees or less, for which the figure is its own image. So at the right, these lines also act as lines that create rotational symmetry. So a square has rotational symmetry of 90 degrees. The third type of symmetry is point symmetry. A figure has point symmetry if the figure has 180 degrees rotational symmetry. Each segment joining a point and its 180 degrees rotation image passes through the center of the rotation.
So, the first type of problem that we'll find in this section is how many lines of symmetry does a shape have? So, first we're going to find how many lines of symmetry does a regular hexagon have. So, first we sketch a regular hexagon and then we draw the lines that helps the hexagon reflects on itself. The lines pass through the midpoints of a pair of parallel sides, and we also draw the lines of each diagonal that passes through the center of the hexagon. So if we count, the regular hexagon has 6 lines of symmetry. So next, we're gonna draw a rectangle um, that is not a square, and we'll see how many lines of symmetry does the rectangle have. So 1, the midpoints, but we can't draw the diagonals on the rectangle because if we try to fold a rectangle paper, we can't fold it into 2 triangles.
So the second type of problem that we'll come across is one that asks us to identify rotational symmetry. So the first question, question A, is a triangle. The triangle has no center point about which the triangle will rotate onto itself. So this figure does not have rotational symmetry. In question B, we have a star. The star has rotational symmetry because it has an angle of rotation of 72 degrees where if the figure rotates, it will appear the same. And now we're going to talk about symmetry in three-dimensional objects. Three-dimensional objects can have various types of symmetry, including reflectional symmetry in a plane and rotational symmetry about a line. The first example is reflectional symmetry. So we have a cube and a plane is inserted into the cube. The plane divides the object into congruent halves. On the second example, this is an example of rotational symmetry. So we have a cylinder and a line is in the middle of the cylinder. So the objects can be rotated about a line so that the image matches the pre-image. A question that we will often find in this chapter is a question that asks us to identify symmetry in a 3D object. So in question A, we have a bowl, and a plane can be inserted into the bowl to divide the bowl in half, and the bowl can also be rotated about a line. So the bowl has both reflectional symmetry in a plane and rotational symmetry about a line. In question B, we have a pitcher, and a plane can be inserted into the pitcher to divide the pitcher into two congruent halves. So the pitcher has reflectional symmetry in a plane.
Okay, so now we're gonna review. So the first question: does the figure have line symmetry? The star. So we know that it has line symmetry because if we put a line over here, it will divide it into halves, and there are many lines. And number 2, does the figure have rotational symmetry? So it does, and if we draw an angle from here to here, this angle, This is the angle of rotation. So it is 60 degrees. Question 3. What types of symmetry does the three-dimensional figure have? So we know that if we put a plane over here, it will divide it into half, so it has reflectional symmetry. And if we add a line, it rotates about a line, so we know that it has rotational symmetry. And number 4, if a figure has point symmetry, must it also have rotational symmetry? So a point symmetry is angle of rotation of 180 degrees. And a rotational symmetry is it will look the same if it has a rotational angle of less than 180 degrees or equal to. So we know that point symmetry is a type of rotational symmetry. And number 5, your friend thinks that the regular pentagon in the diagram at the right has 10 lines of symmetry. Explain and correct your friend's order. So if we actually count, there is only 5 lines over here because he counted both sides of the line. That's why he got 10 lines. And the last question, the word checkbook has a horizontal line of symmetry. So if we put a line of symmetry over here, we know that it has reflectional symmetry because it divides it into halves. So we gotta find other 2 words which is true that has the same horizontal line of symmetry. So we know that C, O, E, C, D, K, they, if we divide it into halves, they'll look the same. So cold and bed. Yep, that's all we have for today, and thank you.